Now this remember this, that we can move y to the left because we could not see any way of changing it into a separable equation. Everybody fine with that? Okay. And so this looks like of that form that we did last time. What was it? Linear equation. Remember that? Okay. That is, see here I have a function of t. Here I have a constant that can be treated as a function of t. Everybody fine in the room? Okay. So who will be the integrating factor, or what is going to help us find the solution? Say it again. Remember this, that is, see this here, I take this coefficient, right, and I do what? I take e to the power, I know it's what last time was too long ago, wasn't it, right? Okay, what's p here? -1. Thank you, Brandon. First of all, is this coming back with everybody? Okay, remember that? Say that again. Or because of this, Alex, I look at the function of t that I have here, the coefficient of y, that's entirely a function of t. Right, but and it has to be a function of t, and here since I have a constant, I can treat that as a function of t. Everybody comfortable? Yes, go Jose. Oh no, I did this. Remember this right there? It's written that you can compare it with the linear equation that's sitting right on the right on the board, right? Okay, makes sense. Good. Everybody fine? So that becomes what? E to the. Very good. Thank you. We will get. It will take plus c into account later. Okay. Everybody good? Okay, so now the solution will be what? What our solution is going to be like then? One sec. Y times e to the what? -t. All right. And then what we have is integral of t times e to the what? -t dt, and we'll bring the constant into play in a moment. Everybody fine? Okay, Raphael, sir? Yeah. So far so good? Okay. Now tell me, how am I going to integrate? Go ahead, Alex.
Why are you putting the y down there?
Say that again?
Why are you bringing the y down?
Oh, I did this. See this here? Okay. Let me just recall these steps from last time. See, it's a consequence of this. Okay. That is, now if you multiply this equation, okay, are you with me? With e to the what? -t, right? Okay, e to the then again what? -t, and then again what? E to the -t. Are you with me, Alex? Right? Then see the left hand side. Okay, that just becomes what? That becomes derivative of y times e to the -t, right? Makes sense? And then what you have is this. Are we good on this? Now when we integrate on both the sides, what will happen? This function, and this is derivative of this quantity with respect to t, so antiderivative will just get that quantity, right? And on the right hand side we are going to differentiate this, right? Okay, now recall your favorite course, that is calculus of single variables. And oh, okay, see what happens is this, Alex, look right here, that is, okay, there we are. I'm going to integrate both the sides with respect to what? T, right? See that, Alex? Are we good here? So, what did I do? I took the antiderivative of the derivative with respect to t. So, what is going to happen? We're just going to get the original function back, right? Mandy, you're very serious. Is that looking good? Okay, very good. Jason, everything good, sir? Go ahead, Sadiq.
Yeah, actually, I'm trying to figure out the second line. How we directly come to the line.
From here to.
No, yes. How we read it.
From here to here?
No, that the highlighted one. This is the solution line. From the first to the second. The
From,
second line, yeah. The one which we highlighted.
I have this, right?
Yeah.
Okay. After this, what I did was this. I multiplied the original equation by e to the negative t, right? And got that, okay? And this one is like we are doing it by observation here. But if you didn't like observation, as I said, you can just use the, yeah, exactly. But since Alex was interested in the details, I just used that as an excuse to go over that. Okay, Joy, sir.
In the seven lines in the certain lines, just
yeah, I just did it by observation. Okay, that is if you look at the product rule. So it looks weird to listen. The third line was the. Okay. All right. Yeah, you look happy now. Okay, Rob, how are we doing, sir? Okay, good. Everybody clear?
Getting used to recognizing.
Right, but as I said,
from the second, and that would just come with practice.
Right. Oh yes, it will. Oh, definitely. If you're kind enough to practice for us, that will be really great. Who has this done? Who has this done? Anybody? Okay. Well, just a second. Yeah, go ahead. Negative t e to the negative t, right? And then very good. Then negative. We are doing what? We are using by parts, right? So negative. Then we will have again negative e to the negative t dt, right? Everybody fine? And so this will simply become negative t e to the negative t, and then again minus e to the negative t, right? So again, which procedure did we use here? You go ahead, you told us the answer. Which procedure did you use integration by parts, right? Okay, very good. Now, if you forgot how to do integration by parts, then I have posted links to review that for you. Let me show you really quickly. Okay, if you go to our course page, okay, then what you can see is this, that where is our course? Where is it? Right here. If you go into the unit 3, no, unit 2, unit 3, okay, everybody fine on this? Then I have posted, just a short lesson on reviewing integration by parts, all right, okay, and also a video to review integration by parts in case you forgot it, all right, or if you remember it, you don't have to worry about any of those two. Is everybody good?
Could you do that integration of parts?
Yeah, okay. Okay, let's check. Yeah, we are reviewing integration by parts, and I'm going to go over that very quickly. All right, go ahead, Brandon.
Jason.
Oh, Jason, I'm so sorry, Brandon.
I'm just going to say that right side of the front cover has a lot of more basic.
Oh, exact. Thank you so much, Jason. Oh, that's a very helpful information, very helpful. Because if you open the book, yeah, on the first cover page, it has all everything recorded. Right. So if you recall, there's something called integration by parts, right, Raphael? So I need your full attention because I'm doing it on your demand, right? Okay. So what I did was this. In this case, the choice is pretty obvious. Okay. I am taking u to be t because notice this. U is going to be differentiated, right? And v is going to be what? Integrated, right? Everybody fine? So I'm going to take this. Is everybody clear on this? Makes sense? Right? So this is the rule for integration by parts, right? Okay. And so what I did was I took u as t and dv as what? This portion, right? Makes sense? And this, we are going to need v and du, right? Du is pretty straightforward here, isn't it? Du equals what? Dt. For v, I have to take the antiderivative of e to the negative t, right? So that will be negative e to the negative t, and we are not bringing the constants in here yet. Raphael, how do we look? Good. Thank you, sir. Okay. So if I apply this here now, okay, then what will happen? That this integral, right, okay, will be u is t, and then v is negative e to the negative t. We got what we got? Simply this. Everybody good? And then we saw v is negative e to the negative t dt, right? Makes sense? Or no? Everybody good? So if you look at this whole thing, this negative will become what? Positive, right? Okay. All right. And then when we integrate again, that sign will become what? Negative, right? Okay, that's okay. Right. E to the negative t. Now, is everybody in the room on board now? Kareem? Makes sense? Good. We are just doing routine calculation, just to warm up, okay? All right, good. So we lost the original question, right? Didn't we? Where is it? Right, right. Oh yes, here. Here. They all look so. Right. Yeah, right. Don't write anything down. I'll post it on the web page right tonight. Thank you so much, Alex, for your kind cooperation. Okay. All right. Yeah. Mehdi was so amusing. That's okay. That's okay. That's okay. Okay, that's all right. So we got y e to the negative t, all right, equals what? This whole thing, right? And then plus what? Plus a c, right? How do I determine my c now? How do I? Very good. Thank you. Thank you so much. Okay. So what was the initial value? Does anybody have it noted? Because I don't want to. That's very helpful. So y at 0 equals 2. So if we use that, excuse me, then here I have a 2. This is a 0. Then I have a 0 and a 0 here and a 0 here, right? Everybody good? How much is e to the 0? So this will be a 2, right? Makes sense? What is the first step here? That's a 0. Thank you, Mehdi. Then e to the 0 is 1 again. So what my c turns out to be? My c is 3. That's very nice, right? So what I got here? I got the following, that this is 3, and if you want you can multiply by e to the t, and that will solve this explicitly in term, for y in terms of what? T, right? Everybody clear? Okay, so I can multiply by e to the t, right? Makes sense. And then what will happen? All the e to the negative t's will disappear, right? One day. So this is gone. This is out. And Alex, we are on record, remember? So if you guys are talking about anything, then even presidential candidates are not spared. Okay, right? Okay. If you are watching the news.
Where's that posted online? I can't find it online.
What? I posted.
Blackboard.
Go to Blackboard. I post everything, Alex. Look right here. See that here? Everything has been. I even posted this video. See?
The video.
Here is the video. See right here. Yeah, it is. You just have to go there, Alex, and you don't even have to. Okay, so see, everything is there. Okay. If there's one video, I'll put more videos. Okay. Okay, I'll say video on the top. Okay. So if you're missing my voice, my accent, go ahead and hear it. All right. Okay. All right. Thank you. Everybody good? Okay. So this is what? Okay. So we have this, and I don't have to do that. I don't even know why am I doing it, but I'm doing it anyways. I'm factoring that. But as I said, that was not necessary at all. Okay. Everybody happy? Right? Good. Thank you, Edwin. Thanks for. Now, this is just, this here. I just want to get some pleasant memories from last Thursday. Solve it, please. Look here. The solution is sitting right here for you. Yes. Yeah. What's the solution of that? See this here? Louder. See, this means what? D of x, y is 0, right? Makes sense? So then what does it mean? X, y equals a constant, right? Everybody fine? Okay, so it's called an exact differential equation. Okay, everybody fine? Why? Because what was the solution? What was the solution? Yeah, xy equals constant, right? And oops, I don't know why I did that. Okay, the solution is xy equals constant, and if I did this, took the derivative of, or took the differential of xy, all right. Now if you look at differential of xy in the strict sense, then that goes like what? The partial derivative of xy. What do I mean by partial derivative? Differentiating this function with respect to x, treating y as a what? Constant, right? So this is what the differential for two variable looks like, right? Then I have what? Okay, I'm losing my symbols right here. Okay, xy divided by what? Y. Very nice. Dy, right? And that simply becomes what? Y dx plus x dy, right? Everybody fine? Jason, is that making sense, sir? Okay, good. Frank, you're very serious. Looks good. Okay. It's kind of a differential of a product, right? Okay. Yeah, I use the product rule and what? For
What do you put x1 to c?
Oh, that is the solution, right? And xy is c. When I take differential of c, that becomes what? Simply 0, right? Makes sense? So what you can do is, so in this case you call it exact because when I take the differential of the solution, I get the differential equation just the way it was, which doesn't always happen. You have seen that and you will see that more, okay? Everybody fine? Makes sense? Okay, good. So, okay. So now, if I have to solve this and I would like to determine whether it is exact or not, tell me who is my m here? Who is my m? Else x square minus y. Everybody clear? And n is what? Minus x, right? Very good. All right. Now somebody tell me who is dm over dy? Who is that? See, when I'm taking partial derivative with respect to x, right? Okay, so with respect to y, I'm sorry. Okay, negative 1, right? Because x will be treated as a constant, right? Okay, all right. Let's take the other one. Where is my? So we got the. Oops. Let me just first. For some reason, this guy didn't work here. Here. So we got what? Okay. So x, and that is also okay. So this will be exact. That's a verification. Okay. We'll say okay, this is exact. Well, how does it help us, right? So let's see how it would help us. So what happens is, oops, sorry about that. If fxy equals c, if that is a solution, okay, pretend that that's a solution, right? So if that is a solution, then what we know, we just found, we just saw that, or you saw that in the previous calculations, that who is df over dx? Remember that? Who was that? M, right? And who was dx over dy? Or df over dy? Yes, sorry. df, yeah, that's what I meant. Thanks. dy, that equals n, right? Everybody clear? And what is our objective? Tell me, what are we trying to do here? We are trying to find what? The solution, right? And the solution is what? This function f, right? So how would we obtain this function f? When you know the derivative of f and you have to obtain it, right? What would you do? You'll take the antiderivative, right? Everybody clear? Gabriel, how do we look, sir? Okay. So if I look at this, so first of all, this tells me that this quantity equals what? Sorry, d partial of f with respect to m equals what? Okay, x square minus y, right? Everybody fine? So if I want to obtain my f, right? Everybody clear? If I would like to obtain f, then what I would do is I'll integrate with respect to x, right? Treating y as a what? Constant. Everybody in the room fine with that? Okay, good. So if I did that, okay, then I have f equals, who is the antiderivative of x? Quickly, please. X square I meant, I'm sorry. X cubed over 3. Thank you. Okay, now y is a constant here, right? See, x, okay, all right, I'll write xy. I was writing yx, but I'll write xy, all right? Everybody fine? Okay. Then plus I will have what? A constant, right? Okay. Now, what do we mean by a constant here? In this case, we are treating anything that involves y, all right, or not x as constant with respect to x, right? Everybody fine? Okay, Sadek, is that good, sir?
Constant is a constant.
Constant, but the constant in here can be a function of y. Why? Because anything that involves y, we are treating that as a constant. So when you're taking its partial derivative, right, then the partial derivative of gy will become 0, right? Everybody clear? So gy is what? Gy is a function of y only, no x in there, right? Everybody good? So, louder. If I write c, then we are done, right? If it's an absolute constant, right? And here, yeah, we have to work a little more, right? Don't we? Because we are not done. Say that again. We have to find the y. Yeah, we have to still determine g of y, right? Yeah, see, okay, Mehdi, when we, if I was doing exactly, if I was integrating n with respect to y, then it would have been a function hx, right? But we are not going that route because once we chose this one and decided to do it that way, then we are just going to see. Say that again, Mehdi, question? No, it's all right. Okay, good. So we got that, right?
When you had the minus xy, it's also optional. You have to type it.
I have to have. Why would that be optional?
No, because earlier Jose said.
This I was writing yx and somebody forced me into xy. They are the same thing, right? That was it, right? Exactly. No, you didn't miss anything. No, I was writing just like if I'm integrating, say, pi, right? I will write pi x, right? But if somebody wants to write it as x pi, I can't, and especially if they answered it first, right? Okay, good, very good. Now, notice this. Okay. So I know that f is this kind of quantity, right? Everybody good? Now I know this, that if I took what? df dy, who that will become? Help. That becomes n, very good, which means what? Dy, n is how much? How much is n? Y square minus x. That sounds very good, right? Okay. Now you got f sitting right here, right? Okay. So if I took df dy, right, using this here, okay, what will be d dy of that? What will that be? Partial with respect to y of the shaded quantity? That will be 0 because I'm treating x as a constant. Joey, are you comfortable, sir? Okay. So that means that will be 0, and who this will be? Negative x, right? So that means negative x. I'm not writing 0 plus negative x because I have very good attention right now from you all. And then I'm writing g prime y because you'll be differentiating g with respect to y, and g is a function of y only, right? Okay. Everybody good? Edwin?
So you just
Just I differentiated f with respect to who? Y, right? And that equals what? Minus x, right? So what do we get then from here? What happens to the negative x on the left and negative x on the right? They simply will cancel each other, right? Everybody good? Okay. So, Young, am I making sense, sir? Yeah. Good. Okay. So, what do we get from out of it? We simply get that is derivative of g, which is a function of y with respect to y is what? Y square. So how do I find the antiderivative of g? How do I? Louder? Just integrate it, right? So my gy will be, who is the antiderivative of y with respect to y? Y cubed over 3. Those of you who took multivariable calculus, remember when you were finding the potential function, you used similar technique. And those of you who did not do it, did not take multivariable, it's okay. When you take it, at that time you'll just go ahead, Raphael, sir.
I'm sorry, can you walk me through, I understand everything up till the middle of the third line.
This one here?
Yeah, so
okay.
Why didn't you continue on to go F?
Okay, here. So my
and
f,
differentiate with respect to y.
So this is the function. I differentiated it with respect to y, right? We were together, right?
Yeah.
And this one, I'm not differentiating. I'm putting the derivative equal to this quantity, right? So this stays as it is, right? See this here? Okay. So we have, so what we got here? So yeah. Right. And yeah, thanks for that conversation. If it didn't work out, let me know. I'll still explain it. Okay. So what happens now? This is the. Oops, sorry about that. This is the what? This is rather not the solution, right? And we will see will depend on the initial conditions, right? Everybody good?